Welcome everyone. In this video we're going to look at chemical kinetics, the study of reaction rate. This is a short introduction to the topic, exploring the factors that impact rate. There are more videos to come describing the Maxwell Boltzmann distribution. More details are in the description. Let's get started. Rate of reaction can be explained in terms of collision theory. For a reaction to occur, reaction particles must collide with enough energy and in the correct orientation. A particle can be any chemical species such as an atom, molecule, ion or radical. For A-level, orientation is not really considered. Reactant particles are moving. Reactant particles also have mass, and therefore reactant particles have kinetic energy. Some collisions do not result in a reaction. These are known as unsuccessful collisions. Activation energy, EA, is the minimum energy needed for a collision to be successful, i.e. a collision that results in a reaction. Let's take a look at an example. D and E are reactants and react in a 1:1 ratio to make product G. Although D and E react in a 1:1 ratio, they can be present in any ratio. In this example, there are more particles of reactant D than there are of E. We can say that D is in excess. At the start of the reaction, particles of product G have yet to form. As the reaction proceeds, reactant particles collide, and if the collision is successful, a product particle is formed. In the diagram, we can see that a red and a blue particle have reacted and a green product particle of G has formed. The reaction continues until one of the reactants is used up, reactant E in this case. At the end of the reaction, no more of the product can form. The factors that impact reaction rate do so by altering either the likelihood of a collision or the energy of a collision, or both. We will deal with the presence of a catalyst separately. Let's look at likelihood of collision. If reactant particles are closer together, there is a greater chance that they will collide. If collisions are more frequent, successful collisions are also more frequent. If the pressure of a reactant gas is increased, there are more particles in a given volume. If the concentration of a solution is increased, there are also more particles in a given volume. The top row shows the particles at the start, middle and end of a reaction, the same as before. The bottom row shows what happens if the concentration of reactant D, the red particles, is increased. The blue particles are now much closer to many red particles. There is a greater chance that the red and blue particles will collide. This leads to more frequent successful collisions and a faster rate of reaction. The likelihood of a collision increases when there are more particles in a given volume because the particles are closer together. Rate of reaction will increase if the concentration of a solution or gas is increased. It will also increase if the pressure of a gas is increased. Increasing the surface area of a solid reactant will also increase the likelihood of a collision. Reactants D and E collide to make product G. D is a solid, whereas E and G are not. At the beginning of the reaction, only reactants D and E are present. D is used up as the reaction proceeds, and at the end of the reaction, none of reactant D is present. The diagram on the left shows reactant D as one solid piece, whereas the diagram on the right shows the same amount of reactant D in 3 smaller solid pieces. The surface area to volume ratio of reactant D is greater in the diagram on the right. The greater the surface area to volume ratio of solid reactants, the greater the likelihood of collision and therefore the faster the rate of reaction. Let's look at temperature next. All particles have a greater velocity when temperature is increased. A small increase in temperature will result in a large increase in reaction rate. This is because increasing the temperature increases the likelihood of a collision and the energy of a collision. Collisions are more frequent and more particles have greater than or equal to the activation energy. Finally, let's look at catalysts. A catalyst increases the rate of a chemical reaction and is regenerated at the end of the reaction. Catalysts provide an alternative reaction route with a lower activation energy. More particles have energy greater than or equal to the activation energy of a catalyst. This leads to more frequent successful collisions. Here is a summary of what we have discussed. For a reaction to occur, reactant particles need to collide with sufficient energy. A collision that results in a reaction is a successful collision. The rate of reaction increases when the frequency of successful collisions increases. Rate of reaction depends on frequency of collisions, energy of collisions, and activation energy. A greater concentration of gases or solutions, or a greater pressure of gases, or a greater surface area to volume ratio of solids will all result in a faster rate of reaction due to the increased chance of a collision. The explanations are given in the table there. At an increased temperature, particles will move more quickly. This will increase the chance of a collision and increase the energy of a collision. More particles will have energy greater than or equal to the activation energy. A catalyst will lower the activation energy of a reaction. More particles will have energy greater than or equal to the lowered activation energy. When asked to explain why a change in conditions increases the rate of reaction, the final sentence is really important. State, this leads to more frequent successful collisions. Thanks for watching. I hope you found the video useful. Please post in the comments if you have any questions or suggestions. Take care and good luck with your studies.